Today in Capechi's Corner, we're going to look at solving equations with variables on each side of an equation. We're going to go back to the vocabulary a little bit later with the key concepts. All right, let's see what happens here. Let's look at the steps. You're going to look at, can you get rid of the distributive property, getting rid of the parentheses, can we combine like terms, both? We're just really building from what we've been doing the last couple of lessons. So we're going to move the variable to one side. That's what we're going to do first. Variables to one side, constant to the other, and then we're going to solve. Okay, so let's look at the first one. So I always like to start with the variables. You can move it to either side. I like to keep my coefficient positive. So by moving the negative 4x there, I'm going to get a positive 3x, which is what I would prefer. It's not wrong if you do it the other way. I move my constants to the other side. So now, so far, I have variables on one side. I have constants on the other. I just really have to isolate that variable. And for the first one, I have x is equal to negative 6. Okay, let's look at the next one. We're going to distribute on this one, right? You got to do order of operations, parentheses first, grouping symbols. And then I have negative 6 minus 2n on the other side. Again, there's my wall. I'm going to move my variables first. I'm going to decide to move that 2n to the other side. And I end up with 9n minus 7 is equal to negative 6. Again, there's my wall. I'm going to add 7 to both sides. I have 9n is equal to 1. And again, my last step is divide both sides by 9. So I have n is equal to 1/9. Final answer. Okay. In letter C, we can actually cross multiply or multiply both sides by 4. So I want to get rid of that denominator. I want to multiply both sides by 4. That will get rid of that. So I have 20y is equal to 12y plus 16. Same idea, I need to bring the variables to the one side. Since the variable of y is already on the left, I'm going to kind of just keep that going. Divide both sides by 8, and y is equal to 2. Now, if you want to check your answer, you can. You just take your solution and you substitute that back in whenever you saw a variable in the original equation. In our next example, we're going to look at some areas and try to find the value of x. So in example 2, we're looking at a rectangle. Here's the area for that. And then we have a triangle. Here's the area for that. It says find the value of x so that the figures have the same area. So the first one is a rectangle. So that area we're going to multiply, right? I'm going to bring that up here. We want to know when they have the same, and the equal sign. Okay. So in the triangle, we want to have 1/2 times my base is 12 times my height is 2x minus 6. So I'm just going to bring that up. Okay, so let's look at the left side. That gives us 5x plus 20. The right-hand side, I'm going to multiply this first. This gives me 6. And then I have 2x minus 6. So I'm going to distribute that. I'm going to bring that down. So I have 12x minus 36. Now again, I'm going to bring the variables to one side. Bring the numbers to the other side, or the constants. I'm going to kind of come back up here. So I have 56 is equal to 7x. Divide both sides by 7. So x is equal to 8. Now the good thing about this, it's very easy to check. So if I go back to my original, so this is 5. If x is 8, 8 plus 4 gives me 12. 5 times 12 gives me 60. I'll do the same thing with the triangle. So I have 1/2 times 12. I'm going to work down here. That gives me 6 times, and then we have 2 times 8 minus 6. Well, 2 times 8 is 16 minus 6. That gives me 10. So 6 times 10 is also 60. The areas are the same, so that I know that x is equal to 8. I did that correctly. All right, let's look at the next one. Okay, so the same thing here. We have our rectangle is 10 times x, there's 10x. Now we have to be really careful with this one here, right? We're not going to multiply those. That's a side, that's a length. That's like I would use a ruler. So I'm going to add the two together, which would be 3 plus x. So in this case, the formula would be 6 times, right, length times width. So I'm going to bring that up here because I want to know when they're going to be the same. So I have 10x is equal to 18 plus 6x. Again, bring the variables to one side. Divide both sides by 4. And x is equal to 4.5. Again, we could substitute that in, so that would make this side here 4.5. 10 times 4.5 gives me 45. I'll do the same thing over here. 6 times 3 plus 4.5 gives me 6 times 7.5. You multiply them together and you also get 45. So the answer here is 4.5 centimeters. Okay, let's look at our last one here. It here says solve each equation and state whether the equation has one solution, no solution, or is an identity. Okay, for this, I'm going to go back to the beginning, the top of our notes to talk about that now. So everything we've been doing so far has one solution. You solve it, you get x is equal to a variable, x is equal to a number, or y is equal to a number, whatever it is. There's only one answer that will work. The next thing we have is when we have no solution. What that means, there is no value of the variable that's going to make it true. It doesn't matter what you use, fraction, decimal number, there's nothing that's going to make it, should we say, work, right? An identity is the opposite of that. Everything works. It doesn't matter what number you put in, all values are going to work. So let's do some examples. It might be a little bit more helpful that way. So let's get started here. So again, I'm going to distribute. So I have 8g plus 48. 5g plus 3g plus 48. Again, I'm just trying to get g by itself. So on the left-hand side, I have 8g plus 48. Combine my terms on the right side, I have 8g plus 48. Now at this point, what do you notice? They are exactly the same. If I were to keep going, like if you don't notice that, you could stop that now. That means this is an identity. This means all values for g, that's the variable we're working with, will work. But let's just say I kept going. I would said to always move the variable first. And you have 48 is equal to 48, which is true. When it's a true statement, everything works. Okay? Let's look at our next one. We have 5x plus 5 is equal to 15x minus 12 minus 10x. Left-hand side is already kind of cleaned up. Let's look at our right-hand side, and we have 5x minus 12. Now, at this point, you can see that they're not exactly the same. Not really sure what that's going to do, but it's definitely something to notice as you start to do more, right? So again, I'm going to move my variable first. And I have 5 is equal to negative 12. This is false. That's not true, right? 5 doesn't equal negative 12. 5 equals 5. So in this case, we say no solution. When the variable zeroes out, when we get a false statement, it means that there's no solution. If the variable zeroes out and we get a true statement, we know that it's an identity. All values will work. Okay, let's try this last one. I'm going to bring my 3w to the other side, and I have 2 is equal to 2w. Divide both sides by 2, and w equals 1. In this case, right, there's one solution, right? Just one. The value is 1. And that's the same way if another example would be like if x is equal to 12, right? There's one solution. That's what we've been doing up to this point. Okay, thanks so much for stopping by today. Have a great day.